Happy December to you all.
Yeah, can you believe that?
Yay.
Just a few more weeks. This week, next week, and then are we reviewing for
Exams.
exams? Are we just reviewing that last week of exams?
We'd have to start before.
Yeah. We're nearing the Christmas finish line, friends.
Hey guys, I want you to look at this. Multiple choice question. After you're checking your homework. What's with that? Why do you guys dress up today?
Cheers, Fairleigh, right?
Yeah, we have Federal League this weekend.
We should have a math department spirit week.
We should.
have no idea. Right? What? How much? I was in You watch video? No. I was on vacation. I didn't bring my laptop
Where
with
were
me.
you?
Florida.
Fly home yesterday?
I like 8.
I had all night to watch it.
I watched last night.
It was a 2-hour plane ride.
Nothing better to watch
Yeah.
and listen to the soothing voice of Mr. Parker and Mr. Westphal.
I mean, that
Talking
would
about
have made you
lines the best
feel.
fit.
I don't bring my laptop.
Especially if your plane was gonna. What voices would you want to hear last?
It's probably dead.
Alan.
I doubt.
You start talking to yourself? Oh my gosh, here we go. We're good.
My phone won't let me download Canva.
I hear a lot of excuses going on.
Mr. Westfall, I'm bringing mine on vacation, so I can do that.
Well done.
I had to.
That's it, Mary.
Hey, you're so sorry.
You know what? When you're not here, we'll just give a little shout out on the thing. How you doing, Mary?
I appreciate that.
All right. Hey guys, look at this scatter plot involving cost of renting and the distance from the center of the city, and answer the question. It's pretty obvious, I think, what the answer is. What does, based on the scatter plot, what does the number 1275 represent in the situation? Which one of those, A, B, C, or D? See what you think. What's true, guys, in most inner cities? And I'm talking about, there's some bad parts of inner cities. I'm talking the nicer parts. Like when you rent in downtown New York, right? New York. What's the rent like there? It's way what? It's crazy, right? It's crazy. So as you go away from the center of the city, what's happening to the cost of rent? It's going what? It's going down. Okay. So what do you think the number 1275 represents? Look at those 4 choices, and I'll give you another minute and we'll read them. Excuse me. Nine. Did you guys get? I got in the habit of staying up. That's the worst part. Like you stay up later on your days off, and you start back. It's like I have to go to bed early now. I've stayed up late the last 2 nights. All right. So, A, bless you. The estimated rent for a house in the center of the city, is this what 1275 represents? Is it that? The estimated number, minimum rent for a house far away from the city? Well, far away from the city, are we getting close to 1275? Far away from the city? No, that's out. The estimated change in rent for each additional mile from the center of the city? Well, I hope not. My goodness, if that changes, if that's really like the slope. The estimated change in distance from the center of the city for each dollar change in rent? What the? Guys, what's the only one that makes sense?
A.
Yeah, that's, if you look here, that's about, 1275. Here's 13. Yeah, that sounds like what you're going to pay in the city a month. And again, this was a long time ago, I think, when this was estimated. All right, guys, look at your homework. Look at your homework. How'd we do on one? Come on, Brock, get done with it. You're doing a stare. How'd we do on one?
Pretty good.
The prices increased, guys. You need to look at a scatter plot. When you guys see these on quizzes, tests, on the state test, don't read any questions, guys. Look at what the scatter plot's saying. What is it displaying? Then read the question. All right, guys. As you get more RAM on your laptop, what's going to happen? The cost is going to go up. That's what it is. That's the deal with number one. We okay with two? How many know what? How many familiar with baseball? A couple of you guys. Earned run average is like, as a pitcher throws, how many runs do the other teams earn? In other words, they get by hitting the ball instead of errors on your team, or basically, and that's what earned run average is. If you guys watch baseball on TV, that's what they talk about with pitchers all the time. Their ERA. That's what that stands for. So, guys, the lower the earned run average. Okay, in other words, if we work this way, this is your better pitchers down here, right? Okay, the lower their earned run average, what happens to their win percentage? It goes what? It goes higher. Okay, it goes higher. If there's a big formula worked out, but usually in the pros, if your ERA is around here, sometimes the elite pitchers have a 1.7, 1 point something ERA. It's based on 9 innings and that stuff. But your average pitchers are probably around 3. Okay. In the pros. Okay. All right, now those should have been pretty easy, right? Okay, this is one we have to really look at. And guys, you really didn't have to graph this, okay? But some of you did, that's fine. Guys, what is this point right there? That's my what, Brady?
0, -12.
What is that, Zach?
-7.
It's a y-intercept, okay? Guys, this whole problem is talking about installing what? What's the whole problem talking about? Installing what to save money? Solar panels. Okay? Solar panels. Guys, year 0 is the year you put the solar panels in, right? Why are you going to have a cost of negative $12,000? You have to pay for the what? That's what the y-intercept represents in the question. Does that make sense? It costs $12,000 to put the solar panels in. Does that make sense now? That was kind of a hard question. And then, guys, if let's say we just picked I think the homework picked those 2 points to get the slope, okay? And you guys see it worked out there on the paper, the green paper. The slope is 1.5. What does that represent? What does the slope represent? Okay, well, we got years here, and we got what? Money's doing what? Save per year on your what? So what does 1.5 represent? You save per year. What is 1.5 though? It's not 1 point. You're not saving $1.50. What are you saving? $1,500 per year. Okay. And have you figured that out?
Not around here.
No. What you got a funky system.
Geothermal.
What do you save? Have you figured it out compared to anybody else? Like gas, electric, and all that?
Yeah. Our quote, actually, the guy took all the insulation on our walls and ceiling and everything and did a calculation and said this is what your average heating bill is going to be, your cooling bill is going to be, and then we also get some hot water from it. And so now we built the house new, so I don't know like what it would have been if it didn't have that, but it's supposed I think he had on the quote like for an average house that size what the typical heating bill would be, and then we would have saved $150 a month or something like that.
Okay. Yeah, it's nothing to do with your electric, it's just heating, cooling.
Well, we can't get natural gas, so ours would have either been electric or propane, but our geothermal is all electric.
Okay. All right. And guys, listen, you guys did a great job on the quizzes. You should have been able to write an equation, right? You should have been able to get, go y2 minus y1, get this. And then, guys, if you notice this point right here, 0, -12, I'm done with my equation once I get my slope, right? It's what? Y equals 1.5x, what is it? Minus 12. And again, that's where we started out. Why were we $12,000 in the hole at year one, or excuse me, at the starting point of installing solar panels? Because that's how much it cost. Okay, that's how much it cost. All right? We good? Yes? You want to collect those for me? Just set them on my computer over here, brother. Just pass them over this way, guys.
I'm sorry.
To Matt. All right.
Do they use Desmos?
Huh? Can they what?
Are they using technology to do that?
Do what?
It says you can use technology to find a linear regression.
I don't know if they're using it. We didn't use it before.
What did it do that for you?
We
Everything.
just talked about it. Okay, guys. We're going to talk about correlation and causation today. And they're kind of the same, but yet they're different. And I'll explain that kind of as we go. We talked about the line of best fit. Guys, we talked about the correlation coefficient yesterday, and that's R. And we're going to go over some problems you can see on the state test that I don't think you were on your notes. Oh, we have the notes. You want to pass those out, guys? And you can help them out. Pass those out. Put the rest on my computer there. Thanks, guys. I'll wait a second till you guys get your notes. Thank you. You can set the rest over there. Thanks, guys. Appreciate it. All right. Do you guys remember yesterday? We talked about a positive correlation and negative correlation, no correlation. You guys remember that? What's a positive correlation look like? What's the pattern going to do? Were you here yesterday?
Yeah, I was thinking this.
Oh, okay. What do you think, Matt?
It'll keep going up.
It's going to go almost right. Guys, correlations can go from, and you can see it right there. You can see it. It goes from 1 to -1. Correlation, the R value. Okay, it cannot be more than 1 because 1 would be a perfect straight line going up to the right. What do you think a -1 would look like? That's a strong correlation too, but what kind of correlation would it be? What's that kind of correlation? Anybody? Negative correlation. Okay? So this would be a close to a -1 correlation. This would be close to a +1 correlation. Guys, a 0 correlation would be what? Would there be any kind of pattern there? No, they'd be blown all over the place. There'd be, you wouldn't see a correlation. Okay? So the lower the decimal value to 0, the less correlation there is. Okay? All right. And you can see right here. This is what we were talking about. Hi, Leah.
Hello.
How you doing? Did we get Oh, I'm sorry. I think we're right through that desk. Okay. Guys, here's what we're saying here. Strong negative correlation, strong positive correlation. The closer we get in here, there's no correlation. Okay? No correlation. And there it is right there. This would be a compound inequality right there. All right, so let's look at a couple questions there. Yeah, you see this here. Guys, I think, again, this is, especially on the state testing, we're going to look at a couple questions here. I think anything above 0.6 and above is a strong correlation. So 0.6, 0.7, 0.8, 0.9, 1, strong positive. Then negative 0.6, negative 0.7, negative 0.8, negative 0.9, negative 1 is a strong negative correlation. Okay? So with that in mind, let's look at this question right here. You don't have this on your paper. Okay, it's just up here. Select all the correlation coefficients that represent a linear model with a weak correlation. Okay, now it doesn't mean negative or positive, right? Just is it a weak correlation? Is this a strong correlation? Yes. It's almost -1, isn't it? Okay. Is this a strong correlation? Yeah, anything 0.6 or higher. That's a strong negative correlation. How about this one? Is this strong? No, that one's a weak one. How about 2.04? Is that weak? Yes, that's weak. Strong, real strong. What's the strongest correlation up here? This one is. Then which one? What would be the second strongest correlation? That would be the next one. Okay? All right? And this one also. Read this one here. This was taken off a test, a state test. Again, it really doesn't matter. This just represents the what? Brian collects data on the depth of a river at various points and the velocity of the river at those points. It really doesn't matter. All that matters is the correlation they give you, and it says which scatter plot would probably Brian have made from the data. Well, which, Luca, I don't know why that song came on this morning. It's hilarious. You get here about 6:30. I hit the music and that came on. Luca, what do you think? Which scatter plot shows a -0.9 correlation? Okay, Luca says A. You guys agree with that? Okay. I agree too. It's that one. This one is almost no correlation. These are no correlation. This would be a +9, right? Right? Is everybody good with that?
Yep.
All
He
right.
changed his name halfway through the problem. Must have been a stressful experiment
It was.
from Brian to
Well,
Bryson.
Bryson was Brian's assistant.
Oh, okay.
I don't know.
DeChambeau.
Did you watch that? No.
No, did you?
Yeah, I did.
I heard it was torched.
Oh, he tore his thing. All right, guys, this is, let me try to explain this. This is correlation and causation. Here's causation. Excuse me. Let me kind of explain it this way. If I eat one Big Mac, I'm going to take in so many calories, right? if Corbin eats 3 Big Macs, who's going to take in more calories? Corbin. Now, why? Because he what? Okay, that's a causation. That's a fact. He took in more calories than I did. Why? Because he ate more food. Okay, not necessarily more food, the same type of food, right? Because you can eat more food, and depending on what the food is, you can take in less calories. But that's neither here nor there.
Can I give a quick example?
Exactly, sir. You're up.
I'm gonna try one. Oh, jeez. It's summertime.
Summertime.
Just imagine warm, hot.
I kind of like this stuff because I did this stuff.
That's the sun. That's my
You're
best
just out in
attempt.
Florida.
Very sun.
It's a hot summer day.
I'll be my pool now. I'll be my pool.
You know what happens on a hot summer day?
Is that the sun?
It is.
Okay.
I go get an ice cream cone.
What do you get in art class? Can we get that?
None of your business. Maybe not Honado. That's chocolate. Handles.
Yeah.
You got
Coffee ice cream.
New Baltimore right there.
No.
We get New Baltimore a lot. There is a strong correlation between a hot summer day and how many ice cream cones are sold. Do you agree? Ready for another strong correlation? Hot summer day,
Pool.
sunburns.
Oh.
Sunburns.
Ouch.
Well, I actually got some for you.
Hot summer days can cause sunburns, can't they?
Yes.
Blisters.
And they can cause you to go get ice cream. There is a strong correlation between sunburns and ice cream cones. But do you agree they do not cause one another? The sun causes these, right? Correlation and causation. So there's a correlation between, today it's a hot day. I ate a lot of ice cream and I got sunburns, but did the ice cream cone cause you to get a sunburn? No. But are they correlated?
Yes.
Happen at the same time. Make sense? A store manager records the total visitors and sales in dollars for 10 days. The data are shown in the scatter plot. Take a look at that data. Total sales in dollars is the y-axis and number of visitors is the x-axis. Strong, medium, weak correlation. What would you guys say? Medium to strong maybe. Would you guys agree with that? Okay, let's read the options. An increase in sales causes a decrease in visitors. An increase in sales causes a decrease in visitors. True or false? False. An increase in visitors causes an increase in sales. True or false?
True.
I like it. Let's put a little pin in that one. An increase in sales is correlated with a decrease in visitors. An increase in sales is correlated with a decrease in visitors. False. An increase in visitors is correlated with an increase in sales.
Yeah.
Do you guys agree with those?
Yes.
Both?
Yes.
Yeah.
Or was it different?
I'm thinking. Oh wait, cost. I would say, and again, this is what we talked about last period. The only reason we said B is not
Cause.
cause. It's because
Yep.
people can go in a store. Do they have to buy stuff?
No.
No.
I missed that word. Yep. An increase
Yeah,
in
that's
visitors
tricky.
causes an increase in sales. That's true. Because you could have a lot of flashy stuff out in your storefront, and people come in and are like, "Oh, this is trash," right? And they don't actually buy stuff. So you could have a lot of visitors, but not a lot of sales. Does that make sense?
Yeah.
So cause, no. Correlated, yes.
It's like people going to the Hartville Marketplace.
Ouch.
You go in there, you're not going to buy.
Ouch. Just there for the social.
Yeah, you just especially if you see who runs it.
I don't run it.
Your dad does.
Yeah, but it was like.
I was just kidding. That's why I said it because your dad.
That's not my
Oh
favorite.
my God.
It's fine. It's not my favorite.
Oh, that's quite the name. Ms. Musto.
Who?
Ms. Musto.
Someone would be a clue.
I want canes.
Sounds like it should be in like the Clue game.
Somebody just
Did
said
you-
that.
Did you say
I
that?
literally just said that.
Ms. Musto in the
Mr. Mustard.
in the museum with the Mandalorian.
What?
With the mandolin.
It's the-
Mandolin. That's it.
Isn't that a movie?
Mandalorian is a show, yeah.
Oh, yeah.
The mandolin is an instrument. Ms. Musto in the museum with the mandolin.
Buy them in.
With mustard on her fingers.
All right, she recorded the number of customers she served between opening and noon for the first 20 days of business. Her results are shown on the graph. Which line best fits the data? All right, we got, now these are pretty similar, aren't they? I got a 3x, a 2x, a 3x, and a 1x. Those are slopes are similar. What I would probably do is I would look at that data. And what's the rule for drawing a line of best fit? You want the Sabrina? Did you have your hand up, or is it just floating? All right, Zachary.
You want the same amount on top or below?
I like it. Same amount above as below.
Good.
So when we go to sketch this, is that a good line of best fit?
Yes.
No. That's pretty good.
1, 2, 3, 4, 5, 6, 7,
No. How many are above?
13.
5.
Let's see, 1, 2, 3, 4, 5,
Oh,
6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7. Okay, so maybe I need to go. Now, here's the deal. Here's what I will say. If a data point is way above, it's going to cause that line to be skewed above, up a little bit. It's going to pull it up because it's weighting it up. Same thing for down. Does that make sense? Okay. So that's a good rule of thumb: the same amount above and below, except if there's some what's called outliers. Okay.
Yep.
All right. Well, let's see what we got here.
you know, if you drew a good line of best fit, like Mr. Westfall just did, because doesn't it? I don't know. I think it eliminates two of the lines right now.
Yeah. Which ones?
Which ones do you guys think? Which one of those lines are out? Because isn't the last number the y-intercepts?
What's my y-intercept? 20. And if it's not exactly 20, it should be close to 20. Okay? Right? So which ones are out? 30's out. And
Yeah.
10 is out. You're confused? We're trying to find a line that matches the line of best fit I just drew. Okay, so now we have it narrowed down to the ones that have a y-intercept of 20. Now we should probably find the slope, right? How do you find the slope of that line? Yeah, pick 2 points that would be good. Honestly, if we've committed to 0, 20, that's maybe a 0, 20 is a good point to pick. What else?
Does it have to be on the
It's
line?
like 15.
You want it to be on that line. Yeah. This one's a good one, right?
Yes.
Let's find that one. If this is 10 and this is 15, this is 12 and a half, right? So maybe 13. 13, comma, what's the y value there? Well, this is 40, that's 50. Maybe 48, 49. Let's do 48. Right.
40, I was going to say 47.5.
47 and a half? Yeah. All right. Slope. 48 minus 20 over 13 minus 0. What's 48 minus 20? 28 over 13. That's really close to what? 2. Huh? Okay. What's guessing?
Or like, what if
I picked 2 points on that line.
let's say we did accidentally get 49. Where is it not going to be as hard as
Well, let's see. Okay. Right now it's what? 2.15. So right now I am leaning towards B. Do you agree? Let's do Aaliyah. Let's do the other one. What if we called this 49? What would this be? 49 minus 20, which would have been 29 over 13, which is even more than 2. Even more than 2.15.
So it was,
What would a slope of, now, just out of curiosity, okay? I need to be careful there. I'm not going to do that. The units are different. For a second, I'll tell you what I was thinking. A slope of 1, I was going to say, is up 1 over 1, up 1 over 1. What's wrong about that?
Not all of them are up 1 over 1.
No, but a slope of 1 means up 1 unit over 1 unit, or up 10 units over 10 units. But what's the problem with these boxes? They're 10 by 2.5. That's weird. I can't do that. So I thought about doing it, and then I looked at the units, and I caught myself. I was going to say, well, a slope of 1 would just go up. It would go up there. That's not true, right? So use 2 points. Let's use another point that's maybe good. How about this point right here? Let's use that point. That would be, what's the x value? Well, this is 17.5.
18.
Let's say,
18.5.
I don't care. 18.5, sure. 18.5. And what's the y value? 60. So this would be, let's change our problem. We're still going to use the y-intercept. But we're going to use calculators out. Now we're going to have 60. So we got 18.5 comma 60. We have 60 minus 20 over 18.5 minus 0. What's 60 minus 20? Over 18.5. What do you get? 2.16. Wow, I did 2 different sets of points, and I got this really close to the same slope, didn't I? I'm pretty confident in that answer now. If I would have gotten some number between 1 and 2, I might have been a little more cautious. All right, I would have maybe tested another thing. Does that make sense?
Yeah.
Awesome. Well done. That's it, Mr. Parker, wasn't it?
Hey guys,
Beautiful.
just on the homework tonight, there could be a strong correlation, but that necessarily doesn't mean there's a causal relationship. Causal relationship means it's 100%, that's the reason. Okay? Corbin took in more calories, why? 100% fact, because he what? He ate 3 Big Macs, I ate 1. That's a causal reason why he took in more calories.